Example, to layer linear network, outer product point of view. How does cell Xj contribute to the pattern of firing of layer 2? Here, 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 here. This is Xj cell contribute the, this is layer 2. This is, these are layer 2. How contribute? First, y vector equal to x1 w1. First column of vector. First column of vector. Here. This is second column of vector. Column of w. Sorry, w. Weight. Column of weight w. Here, contribution of xj network output. Here, this place. Xj. Okay. Like this. Okay. Contribution of, this is the point. Contribution of xj to network output. Product of two matrix, that is multiplication of two matrix n into p, n cross p means nth column sorry nth row p column n into p, n row first row, second row, third row, up to n row, first column and second column and p column. So here first row, second row up to p row, then sorry, this is the row, first row, second row, p row, then column, first row, first column, second column up to m. So p MATLAB inner matrix dimensions must agree. In MATLAB inner matrix dimension must agree. Okay, in MATLAB it is okay. Note, matrix multiplication doesn't generally commute AB not equal to BA in the matrix. Then result here, A matrix, B matrix equal to C matrix. N into M. N into M. First row, second row up to N row. First column, second column up to M column. N cross M matrix. Matrix time matrix by inner products this is the A matrix, B matrix equal to C matrix. Cij is the inner product of the ith row, ith row, jth column, jth column, jth column. This is the ith row, ith row, not total this, ith row. So how is how I got CAG? Which one is multiplication? I got this result. This ith row, jth column, jth column. This is ith row, ith row. So CAJ is the inner product of the ith row with the jth column, jth column, ith row. Then got the result. CAJ equal to CAJ equal to summation of k equal to 1 to p aik pki aik here aik. This is pkj. Yes. aik. So we got this. Cij is the inner product of the ith row of A with the jth column of P. Jth column of P. Jth column, ith row. By outer products, that's why here C outer like that, not inner. How you will outer product? This column AC1 into PR1 row plus AC2 here, AC2 here, AC1 here, P1 here, PR2 here. Then we got the result C plus, but plus 2 up to ACB here, PRB. C is a sum of outer products of the columns of A with the rows. C is the sum of outer products of the columns A with the rows. Outer product. This is the outer, not inner. Outer. Outer products of. Okay. This is. They also to be called. Okay, then we will see. Part 2, matrix properties. Matrix properties. Yes, few special matrix properties. Second, matrix transformations and the determinant. Third, matrices and systems of algebraic equations. Special matrix, diagonal matrix, diagonal d1, d2, dn up to, this is diagonal. Okay, diagonal. So diagonal matrix. Okay, this is like scalar multiplication. This is like scalar multiplication. D with the x. This is the D. D1, D2 up to Dn. Corresponding x1, x2 up to x. That's why this is called act as like a scalar multiplication. Scalar multiplication. In scalar what? No direction. Only magnitude, no, only magnitude is only available. In vector both. Direction plus magnitude. Special matrix. Identity matrix. Special matrix. Identity matrix. What identity matrix? Same in diagonal only. 1 1 1. Sorry. 1 1 1 1. 1 1 1 1. Yes. So, I'm bringing through mouse, but we have to here. Special matrix, identity matrix. So I equal to for all A 1 into A equal to A1 equal to A. These are same for all. Identity matrix. Same only will come. Multiplied by 1, no? Diagonal matrix. That element diagonally coming, that's why diagonal. Outer coming outer, inside coming internal matrix. Special matrix, inverse matrix. This is special matrix, inverse matrix. Inverse matrix also. What? A inverse, A inverse, A power minus 1 equal to A minus inverse A equal to 1. Does the inverse always exist? How does a matrix transform square? How does a matrix transform a square? Where, how a matrix transforms square? For example, 0 here 1. Okay, 1 in 0. Y x is here 0, y is 1. Here x is 1, y is 0. Okay,